Okay, here we go with domain and range part 2. Tomorrow we will go over part 3. So just to review, the first two are some of the ones that you just did yesterday. So you should be able to do problems 1 and 2. I didn't number them, so I'll number them in a second. And why don't you try the first problem and the second problem, and then we'll take a look at the third problem. Okay, so let's see how you did with problem 1 and 2. So on problem 1, they have individual points, and the domain is that they're asking us to state or identify the x values. Those are the input values. So, you don't have to use a fancy notation, but we like you to practice using the set notation. So we just need to identify each of the x values. So remember the x values, we have 2 of them that have an x value of 2. We're only going to list the 2 one time because we're not really inquiring about how often we're putting 2 into the domain function or into the machine. We're just saying what's going into the machine. Remember, domain is the inputs, that's the x values, the inputs that are going into the machine. And then we have, this one has a x value of 3. This one has an x value of 4. This one has an x value of 5. And this one has an x value of 6. So those are the x values. Now let's take a look at the y values. So remember, the y values is how high or low the point goes. So notice that both of these points both have a height of 2. So that means we have a y value of 2. Again, we're not going to repeat it. Let me put that in black because I probably can't see that very good. These 2 points both have a height of 3. And these 2 points both have a height of 4. So notice I did not repeat those. So basically we have a 2, a 3, and a 4 coming out of the machine, right? These are your outputs. This is what's coming out of the machine. And these are the numbers that are going into the machine, or the inputs. So those are the x values, and these are the y values. Let's look at number 2. So on number 2, we want to look at how far to the left and to the right the graph is. We're looking at what x values are being used to create this graph. So as you can see, the x values that are being used to create this graph are the numbers between 1 and 4. And notice that we have an open circle here, and we also have an open circle here. So basically we have to write a domain statement that is between, right? That's a compound and that is between the numbers 1 and 4. So we have to write all the x values that are between 1 and 4, and it should be less than symbol with no equal to. So how did you do with that? The range is how high and low the graph goes. In other words, what are the y values that we're using that would make up that graph? So it goes as low as 2 and it goes as high as 5. So basically we're using the y values 2 and 5. So that means any number between 2 and 5 is coming out of the machine. When 1 or 4 is going into the machine, so any number between 1 and 4 that's going into the machine, right? Because your domain is also your inputs. So when these numbers are going into the machine, these are the kinds of numbers that are coming out of the machine. And your outputs are your range. And it went as low as 2 and as high as 5 in open circle, open circle. So we have to write a compound and sentence because it's a between sentence. Did you remember to use the letter Y? Did you remember the lowest number goes on the left and the highest number goes on the right? And did you put greater than symbols? Ooh, no, that's not right. Right? They're not greater than symbols. When you're talking about between, they're always going to be less than symbols when you're talking about between. And then we didn't go back and say if these are a function. So if we go back to number 1, notice that if you drop a vertical line, it hits more than one time. So this is not a function because it fails the vertical line test. Here, if you drop the line, no matter how many times you drop a vertical line, it's only going to hit one time. So therefore, it passes the vertical line test. So it is a function. Now let's look at number 4 and 5. Oh no, let's go to number 3 next. So looking at number 3, do you notice that it's different? That here we have an arrow. This is called a ray. So in geometry, this is known as a ray. A ray is when you have an endpoint and then it goes on forever and ever and ever and ever in one direction. So here we have a situation where we want to talk about the domain, So we want to look at the x values. And when we're looking at the x values, we want to look at how far to the left the graph is. So the furthest to the left is -4. And then do you see that it keeps on going to the right? It keeps on going forever and ever and ever and ever and ever. So we have to write a domain statement where the numbers are solid circle because of this solid, and it keeps on going forever and ever and ever and ever and ever to the right because this keeps on going. So this would keep going and keep going and keep going. So it keeps on going to the right, never stops. So we would not write a between statement because this is not a compound and picture, right? This, don't you just see everything to the right of -4? So don't we write all the x values that are greater than or equal to -4 if we're talking about all the numbers that are to the right forever and ever and ever and ever and ever that don't stop? Isn't that how you write that statement? Now let's look at how low and how high the graph goes. So once again, the lowest it goes is 2. And notice as we go, as this keeps on going, it keeps on getting higher, 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 higher forever and ever and ever. So this keeps getting higher and higher, and it never stops getting higher. It's going to continuously keep going forever and ever and ever. And that's why I'm putting the arrow there. I'm going to put it in black to emphasize. So we have to write a range statement where the lowest point is 2. And notice this is solid. So this is solid. The lowest point is 2, but it keeps on going forever and ever and ever and ever and doesn't stop. Because see, this keeps going up, 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 up. Keeps going to the right, to the right, to the right, to the right, and it keeps going up, 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 up. Right? So all the numbers that are from above 2. And so all the numbers that are above 2, don't you write that as all the y values that are greater than or equal to 2. And then is it a function? If you drop a vertical line, will it ever hit the graph more than one time? Nope, only hits it once, only hits it once. So yes, because it passed the vertical line test. Okay, why don't you guys try 4 and 5 and see how you do? So here's number 4 and 5. You can pause the video and try it yourself and see how you would do. So if we're looking at the domain, we're talking about the x values or the input, what's going into the machine. So we want to know how far to the left and how far to the right the graph goes. So do you see that we have a furthest to the right point? If we follow this down, that's the furthest to the right. And then do you see that this arrow, right? So this is another ray where it has a starting point, and then it keeps on going forever and ever and ever and ever and ever, never stops, right? That's called a ray. And so we have the furthest to the left it goes is 1, and then it keeps on going forever and ever and ever to the left. So I'm going to emphasize that. And this was an open circle, right? This was an open circle, so I'm putting an open circle there. So we have to describe this domain. And don't we see everything to the left of +1? So wouldn't we write all the x values that are less than +1? Some teachers will use fancy notation. They'll use a little set notation, and they'll write x such that x is less than 1. And if you want to practice having higher level notation, we would love for you guys to use this little fancy set notation. So it's x such that x is less than 1. So if you want to practice using that notation, good for you. If it's too much, then you can leave it out. Okay, let's look at the y values. Let's clean this up and let's look at the range. So remember, when we look at the range, we're looking at how high or low the graph goes. And do you see the highest point is 4? And then again, this arrow means that it keeps on going forever and ever. So do you see it just keeps getting lower and lower and lower and lower and lower? So we're going to show that by saying this is the highest it goes, and then it just keeps dropping. Just keeps getting lower and lower and lower and lower and never stops. So we're going to put an arrow there, and I'm going to put it in black just to emphasize because it's hard to read it. And then because we have an open circle here, that means this is going to be open. So we just have to basically write a statement that describes all the numbers below 4, right? We have to describe all the numbers that are below 4. And when we're talking about below, we would say all the y values that are less than 4. Or if you want to, you can write fancy y such that y is less than 4, if you want to use fancy set notation. So if that's too much for you, you can just leave it as y is less than 4. Okay, let's look at number 5. Why don't you pause the video and see if you can do number 5 yourself. Now, we didn't do the function on the other problem, and it would have been a function on problem number 4. So let's see, if we're talking about the domain, we're talking about how far to the left or to the right does the graph go. And notice again that we have an array type problem. We have a starting point, and then it keeps on going forever and ever and ever. So this is going to keep on going forever and ever and ever and ever and ever, right? So when we talk about the furthest to the left it went was -3. If we drop my eyes down, it's -3. And it keeps on going to the right forever and ever and ever, and it doesn't stop. And it's an open circle, because this is an open circle. So basically we just have to write a domain statement that talks about everything that is to the right of -3, right? Everything's to the right of -3, so we say all the x values that are greater than -3. And again, if you wanted to, you can use the fancy x such that x is greater than -3. And if that's too much for you, you can just leave it out and say, nope, it's too much. So let's see, how did you do with the range? The range is how high or low the graph goes. And can you see that it went as high as 5, and then it just kept getting lower and lower and lower and lower? Because this is saying it keeps on getting lower, 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 lower. So I'm going to put a little arrow there to emphasize that. So basically we just need to describe everything that's below 5. So everything that's below 5, wouldn't we say all the y values that are less than 5? And if you want to, you could write the little y such that y is less than 5, and you can use the little fancy set notation. And is it a function? If we drop a vertical line, doesn't it hit just one time? So yes, it is a function because it passes the vertical line test. So I wanted to go back a minute and have you notice number 2. Do you notice number 2 is not array? This is called a line segment. You have a beginning and an end, right? You have a beginning and you have an end. For this one, you have a start and you have a forever and ever and ever. So remember, this graph is called a ray type graph. This graph is called a line segment type graph. So today we're focusing on, so in your homework tonight, you're going to have some that are line segment types, and now you're going to also have some that are ray types. So right where it has a starting point and it keeps on going in one direction, where it has a starting point and it keeps on going in one direction, that is known as a ray type graph. And last night you did a bunch of problems that were more that were line segments, where they had just a piece of a line, so it had a beginning and an end. Okay, so let's look at number 6. So number 6 is another ray. So you have a beginning, and then it keeps on going forever and ever and ever in one direction. So this type of graph is called a ray type of graph. It has a beginning, and then it keeps on going in one direction. So when we're looking at the domain, we're looking at how far to the left or to the right the graph goes. And you can see the furthest to the left it goes is 1, is the furthest to the left. And then it's going to keep on going to the left. So we're going to show that by highlighting that it started at 1 and then it kept on going forever and ever and ever and ever and ever to the left. And notice it had an open circle. So I'm going to bring that open circle down. And then this is the domain. Those are all the x values that are going to go into the machine, or the inputs. So all the x values that are to the left of +1. And then let's look at the range. The range is how high and low the graph goes. Doesn't the graph just sit at 4? It doesn't go anywhere else. It just sits right at 4. In other words, each of these ordered pairs that makes up the graph, right? So a graph is really just made up of infinitely many x and y values. And each of these y values are always going to have 4. So this one is just a y value of just 4. And if we look at the vertical line test, is it a function, yes or no? If we drop the vertical line, it only is going to hit once. So yes, it's a function because it passes the vertical line test. So why don't you pause the video and see if you can do number 7 and 8 and then come back. Okay, so let's see how you did. So notice that number 7 is a ray. And can you look at number 8? So this one is a ray type graph where it has a starting and then it goes on forever and ever in one direction. Where number 8 is not a ray, it has a beginning and an end. So this is called a line segment. That's good to know. If you go to geometry, you know what some of those words are. So it's just a piece of a line. It has a beginning and an end. Line segment. So this one goes on forever and ever and ever. So basically the domain starts at -2 and then continues forever and ever and ever to the right. So I'm going to put an arrow and I'm going to emphasize that. And it has a solid circle right there. So that's solid. So that's solid. And then that's our domain. So we have to write all the x values that are to the right of -2. So x is greater than or equal to -2. So are you using the correct inequality statements? Don't write it backwards. Don't write -2 is less than x. That actually is correct. But remember, we read from left to right. So this is the one we're looking for, right? Because that's how we read. Now, if you wrote -2 is greater than or equal to x, that definitely is wrong. So we don't want you writing them backwards. We want you writing them the way we read, right? We read from left to right. And then what about the y value? So isn't the y value how high or how low? And isn't the graph just sitting at -4? -3 actually. So it's sitting at -3. So we can just say the y value is -3. Doesn't go any higher than -3, doesn't go any lower than -3. It just sits right on -3. And then is it a function? If you drop a vertical line, yes, it's a function. Okay, number 8. Number 8 is a line segment. So notice in number 8, it goes as furthest to the left is -2, and then it keeps on going, and then it stops at 4, where this endpoint is an open circle and this endpoint is a closed circle. So how do we describe this domain? Isn't this a compound and type picture? Don't you see that it's shaded between -2 and 4? And so don't we say all the x values that are between -2 and 4, and isn't this one a less than symbol? And then the 4 is solid, so that should be a less than or equal to symbol. Okay, range. Range is how high or low the graph is going. Do you see that this graph is just going up to +3 and nowhere else? So the range is just +3 on this one. And it is a function because if you drop a vertical line, it passes. And last one. Last one is just another picture type problem. Just to review that, why don't you pause the tape and see if you can figure out the domain and range. In the domain, we have how far to the left and to the right. So isn't the furthest it goes from A to B, which in this case is from 1 to 3. So it goes between 1 and 3 is the domain. So the domain is between 1 and 3, and it's including 1 and including 3. And then the range is how high and low. Isn't the highest it goes 0, because remember that's 0, and isn't the lowest it goes -4. So the highest it goes is 0, and the lowest the rectangle goes is -4. And we're including the edges of the rectangle. So we'd say all the y values that the lowest it went was -4 and the highest it went was 0. And we're including the rectangle. And then if you drop a vertical line, doesn't it hit twice? And then here it hits a bunch of times. So it's a big no, not a function, because it fails the vertical line test because it hit more than one time. So it failed it. So it's not a function. Okay. Part 3 for tomorrow.